What's the point of a coordinate plane? Our goal with a coordinate plane is to be able to draw a picture that shows us all of the solutions to an equation in two variables. Remember, we noticed that an equation in two variables typically has a lot of solutions. It typically has infinitely many solutions. And so just making a list of solutions isn't enough for us to get an idea of what the solutions look like. By drawing a picture that shows all of the solutions, we can get a better idea of what sort of pattern the solutions make. And we can use that picture to answer questions, as we'll see coming up. So we call that picture that shows all of the solutions to an equation in two variables, we call that picture the graph of that equation. So as an example, I claim that this picture is the graph of y equals a half x minus 1. And when I make that claim, what I'm saying is that every point along this line is a solution to that equation. So here's a point on this line, right? This is the point x is 0, y is negative 1. And I can see that 0, negative 1, if I plug in x is 0 and y is negative 1, my equation becomes a half times 0 minus 1 equals negative 1. And that really is true, right? A half times 0 is 0. Minus 1 is negative 1. Here's another point on this graph, right? This is the point 2, 0. So that's the point where x is 2 and y is 0. If I plug those in, my equation becomes a half times 2 minus 1 equals 0. Now a half times 2 is 1. Minus 1 really is 0. So again, that really works. I could say this point. So this is the point negative 4, comma, negative 3. The point where x is negative 4, y is negative 3. If I plug those in, my equation becomes a half times negative 4 minus 1 is negative 3. Maybe we want to use a calculator to check that. We'll take a half times negative 4 minus 1. And as we hoped, that really does give us negative 3. We can even do it with like points that are in between, although it's hard to read their coordinates. It's hard to read the coordinates of this point, but I claim that the coordinates of this point are negative 1.5, negative 1.75. Negative 1.5, negative 1.75. So we'll have x is negative 1.5, y is negative 1.75. In our equation, we're hoping a half times negative 1.5 minus 1 gives us negative 1.75. And again, we can put that into the calculator and see how it works. So a half times negative 1.5 minus 1. We see it really does give us negative 1.75. Now, we wouldn't necessarily actually guess those coordinates, and To figure out the exact values of those coordinates, well, we could figure out the exact y coordinate that goes with x coordinate negative 1.5 by plugging in the same way that we saw earlier in this set of notes. So in this example, I just gave you the line. How can we find a line that is the graph of an equation? From geometry, we know that 2 points fix a line. That is, if we know 2 points on a line, then there's only one line we can possibly draw through them. As long as we're working with a linear equation whose graph is a straight line, as long as we know 2 points on that line, we can go ahead and draw the line. In this example, we're given the equation 3x plus 2y equals 12. We're asked to find two solutions to this equation and use that to draw the graph. And we notice that this equation is linear, so its graph is a straight line. How can we find two solutions to this equation? Well, to find a solution to this equation, we can either choose a value of x and find the corresponding value of y, or choose a value of y and find the corresponding value of x. Now, I like to choose 0 when I can. So I'm going to start by choosing x equals 0 and see where that gets me. So if I choose x equals 0, my equation becomes 3 times 0 plus 2y equals 12. 3 times 0 is just 0, and adding 0 doesn't do anything. So I just have 2y equals 12. Divide both sides by 2, and we get y equals 6. So our first solution is going to be x is 0, y is 6, which is this point on the graph. Okay, so there we chose x equals 0. I could choose a different value of x if I wanted to next, but I like plugging in 0. So I think next I'm going to choose y equals 0. And so then we'll have 3x plus 2 times 0 equals 12. Well, 2 times 0 is just 0. Adding 0 doesn't do anything. So we just have 3x equals 12. That's great. We'll divide both sides by 3. We get x equals 4. So our second solution is going to be x is 4, y is 0, which is this point in the coordinate plane. Okay, so next, I want to take a ruler and set it so that its edge is on each of my 2 points. And then I can try to draw the line that goes through those 2 points. And I think the line is going to be something like this. So we only need the 2 points in order to get all of the solutions to this equation, right? Notice that there are plenty of points on this line that are not among the points that we plotted. Those points also represent solutions to this equation. Now, this method of finding 2 solutions works great if the numbers are nice. But we can see that very easily I could have been in a situation where I found fractional coordinates for my x or my y when I plugged in this way. When we're working with a linear equation in two variables, we will often have it in a certain specialized form, which gives us a simpler way of graphing our equation, that if we're a little bit careful with our fraction arithmetic, we can always get integer points. The form that we're going to talk about is called the slope-intercept form. And the form that we have is y equals a number times x plus another number. So this is a number. This is also a number. The first number, m, is called the slope. The second number, b, is called the intercept. And so this is the slope-intercept form, because it's the form that includes the slope and the intercept. Okay, let's look at some examples and see if we can figure out what information the slope and the intercept give us related to the graph. In example 31 here, we have the equation y equals 2x minus 3. So this is the slope-intercept form. We're matching this up to y equals mx plus b. And so our slope, the number multiplied by x, is 2. What about the number that's added on here? Right, so 2x minus 3 is 2x plus negative 3. In other words, our intercept is negative 3. One really immediate advantage of the slope-intercept form is if we plug in values for x, we can really easily find the values of y. Because this equation is in the form y equals stuff with an x in it. So if we plug in a value of x, say x is negative 2, then y is going to equal 2 times negative 2 minus 3. And we can throw this whole calculation into the calculator if we like, or work step by step. Negative 4 minus 3 is negative 7. When x is negative 2, y is negative 7. In other words, the pair negative 2, negative 7 is a solution to this equation. If we plug in x is negative 1, we'll have the equation y is 2 times negative 1 minus 3. So 2 times negative 1 is negative 2. Negative 2 minus 3 is negative 5. Next, if we plug in x is 0, we'll have y is 2 times 0 minus 3. 2 times 0 is easy, right? That's 0. So we have 0 minus 3 is negative 3. If we plug in x is 1, we have y is 2 times 1 minus 3. So 2 times 1 is 2. 2 minus 3 is negative 1. When x is 1, y is negative 1. Let's do one more of these. If x is 2, y is 2 times 2 minus 3. 2 times 2 is 4 minus 3. And then 4 minus 3, of course, is 1. So when x is 2, y is 1. So we have this table where we have 5 solutions to this equation. 5 solutions is way more than we need to draw a line, of course. So we're going to pick two of them and use them to draw the graph. And I'm going to choose 0, -3, and 1, -1. So 0, -3 is this point here. 1, -1 is this point here. If I draw the line that goes through those points, it'll look something like this. And I'll see also that the other pairs in my table are also points on this line, right? So I used 0, -3, and 1, -1 to draw my line, but the other points in my table also show up on that line. -2, -7 does not, because my y-axis only goes down to -6. But if I continued my y-axis down further, -2, -7 would be on that line as well. So where do we see the slope and the intercept in this graph? Right, so the slope was 2. And what we see in the graph is every time we move to the right by 1 unit, we move up by 2 units. So the first way we see the slope is when x increases by 1, y increases by 2. But there's actually something more general about the shape that we also see in the slope. The more general thing we see about the shape is that as we go from left to right, the line slopes upward. And the thing in the equation that tells us that that is going to happen is that the slope is a positive number. The intercept, similarly, there are two ways of seeing it, a specific one and a more general one. So we see the -3 as the place where the graph crosses the y-axis. And more generally, we're crossing the y-axis at a negative value. In other words, more generally, we see that our line crosses the y-axis below the x-axis because our intercept is negative. Why do I do this positive-negative stuff? Because sometimes when we're working on something like this, we can get a little bit turned around. And so making sure you have the right general shape. Does your line slope upward or downward? Does your line cross the y-axis above or below the x-axis? Can help you make sure that you have the right line. Let's see another example. Here, my slope is a fraction, -3/2. And my intercept is a positive number, +1. I'm going to put the plus in just to emphasize that it's positive. Okay. And when I'm trying to draw a graph, I like points with integer coordinates. So let's plug in some values of x and see what we get for our value of y. So let's start with x is -4. Y is -3/2 times -4 plus 1. And here I'm just going to do the arithmetic on the calculator. So we'll have -3/2 times -4 plus 1. And that works out to +7. Let's just get that line back and change it to a -3. We have y is -3/2 times -3 plus 1. That gives us 5.5. I could make that a fraction, but I think I'm not going to use this number, so I'll just write the decimal. That's fine. Let's get that back again. Change it to a -2. Y is going to be -3/2 times -2 plus 1. And that works out to 4. X is -1. Y is going to be -3/2 times -1 plus 1. That comes out to 2.5. Okay. Well, I'm starting to notice a pattern here, right? I'm getting fractions whenever my x values are not an even number. That is, whenever my x values are not a multiple of 2. I think I'm only going to look at the multiples of 2 here. That makes sense, right? 2 is the denominator of this fraction I'm multiplying by. So if I have a multiple of 2, that's going to cancel out that fraction, and I'm going to get a whole number answer. So let's see. When x is 0, y is -3/2 times 0 plus 1. Well, I can multiply by 0 in my head. Anything times 0 is 0, plus 1 is 1. Then when x is 2, y is -3/2 times 2 plus 1. I'm using the delete key to delete the negative sign and making that a 2. So when x is 2, I get y is -2. Then when x is 4, y is -3/2 times 4 plus 1. I get -5. Okay. So where are we then? We have a bunch of solutions. I want to use solutions where my coordinates are integers. So I'm going to use 0, 1, and 2, -2. X is 0 and y is 1. The point where x is 2 and y is -2. And then we'll draw in the line that goes through those 2 points. And we'll claim that's the graph of this equation. Okay, so let's look again at the slope and intercept and how they show up on this graph. Slope first. On the other graph, we said that when we go 1 unit to the right, on the other graph we said we went up 2. It looks like maybe we go down 3/2, which would be 1.5. I like it better if I go to the right 2 and then down 3. So I'm going to say that the slope says every time we go right 2 units, we go down 3 units. More generally, we said the slope was a negative number. And looking at this graph as we go from left to right, our line slopes downward. So looking at the slope more generally, we say that our line slopes downward. And the reason that that happens is because the slope is negative. The good news is the intercept still means the same thing. Intercept was positive 1. Here's positive 1. We see that we crossed the y-axis at positive 1. More generally, we cross the y-axis above the x-axis because the intercept is positive. So we're going to develop a way to draw the line from just the slope and the intercept without filling in the tables. But then this upward, downward, positive, negative association also gives us a way to check whether we've drawn our line correctly. So how can we draw the line given just the slope and the intercept? Well, first, we'll look in the equation and we'll figure out what the intercept is. That's where the line crosses the y-axis. Second, if the slope is a fraction, we'll look at the denominator of the slope. That's how many spaces to the right we're going to count from that starting point. Then we're going to look at the numerator. If the slope is positive, we're going to count that many spaces up. If the slope is negative, we're going to count that many spaces down. So to use the shortcut to graph y equals 3/4 x minus 2, this is y equals 3/4 x plus negative 2. So the slope is 3/4. The intercept is negative 2. First, we'll go to the y-axis and find the intercept. Then, our slope is 3/4. The denominator is 4, so we're going to go 4 units to the right. So 1, 2, 3, 4. And then the numerator is 3. So we're going to go 3 units up. We're always going to go to the right. We're going to go up when the slope is positive. So a second point on the line is this point right here. Then we draw the line through those 2 points. And that's our graph. Now notice, we didn't really read the coordinates of any of these points. But for example, this point, 4, 1, or this point over here, -4, -5, we can confirm that points that are on our graph really are solutions to our equation. I'm going to do that with 4, 1. The claim is that 3/4 times 4 minus 2 really does give me 1. Putting that into the calculator, we'll say 3/4 times 4 minus 2, and it really does give us 1. Okay, let's see another example of the shortcut. We have y equals -2x plus 5. So our slope is -2, which we're going to write as -2 over 1. We're going to write it with denominator 1. Our intercept is just positive 5. So first, we're going to go to the intercept. That's where we cross the y-axis. Second, the denominator tells us how far to the right to go. We're going to go right 1. And again, it's always to the right. Now, we have a negative slope. So after we go to the right one, we're going to go down 2. And so our second point on our graph is this one. Finally, we draw the straight line through those points, and that's our graph. Okay, there's one other kind of line that we want to look at before we leave graphing linear equations behind for now. The lines we've graphed so far are what are called oblique lines, and they're kind of the normal sorts of lines to graph. But we can also graph horizontal lines and vertical lines. This graph here shows us a horizontal line and a vertical line. And let's just kind of think about the coordinates of points on these lines. So looking at our vertical line first, right, here's a point. This is the point -4, 6. Here's another point. This is the point -4, 1. I'm just picking some points at random. Here's a point. This is the point -4, -3. This is the point -4, -4, and so on. We notice that on the vertical line, the points all have the same x coordinate. They have all different y coordinates, but they all have the same x coordinate. And in fact, that's how we set up our coordinate plane, so that that vertical line just consists of all the points that have x coordinate -4. So we say that the equation of this line is x equals -4. Notice that equation doesn't tell us anything about y, so that implies y can be anything. If all we know is that x is -4, y can be anything, and that's that entire vertical line. On the other hand, let's look at the horizontal line next. So again, I'm just going to pick out some points. So this is the point 4, 2. And then just right over here, maybe this is 5, 2. Here's 1, 2. Here's -2, 2. All the way over here, maybe this is -7, 2. We notice that those points all have the same y coordinate. So we can say that the equation of this line consists of all the points where y equals 2. And since that equation doesn't tell us anything about x, well, x can be anything. And this gives us the general form for equations for horizontal lines and vertical lines. If we have an equation that says y equals something, that's always a horizontal line. And if we have an equation that says x equals something, well, that's always a vertical line. And then if we have an equation that contains both x and y, and it's a linear equation, then we have a line that's at some angle, those oblique lines that are the normal lines we look at.